Welcome to Math 1324, Section 7.2 on the basic operation of sets. Alright, so let's take a look here. When we see these squiggly brackets, this is a set. Alright, and the things inside it are the elements of the set. Now there are a couple important things to know. First, order does not matter. Order does not matter. What do I mean by that? I mean that if you write the set of 1, 2, 3, that's the same set as if you list 3, 2, 1. So the order that you present the elements on the inside makes no difference whatsoever. Think of a set as just a box where you have put items on the inside. And the second thing that's important about sets is there are no repeats. You're never going to see a set that looks like 2, 2. No one writes that. So anytime that you have a set, there's no repeats and it just has one of that item in it. Alright, so let's take a look here. In problem 1, we have this U sitting on the side. It means that it's a subset. And so if a set A is a subset of B, that means everything in A must also be in B. So let's see, I got a set here of 3 and 5. Is every member in this set also in the bigger set? 3 yes, 5 yes, so yes, that is a true statement. In question 2, we have two sets. Both have 4 things in it. The question is, are they equal or not? Well, let's see. Is D in both sets? Yes. Is F in both sets? Yes. J, yes. K, yes. So they both have exactly the same things in it. Again, the order does not matter. Question 3. Question 3 is probably one of the more confusing questions. So what do I have? I have a set consisting of 5. And then I have another set with 8. And in that set is another set with 5 in it. So what does all that mean? Well, think of it this way. Here's 5. Think of 5 as being a box. So here's my box. And inside this box, 5 is in it. I have the other box, which is 8, and then 5 in another box. So thinking of that is I've got this bigger box now. And in this bigger box, here's 8. And inside of the bigger box is a smaller box, and this box contains 5. So let's look here. Is 8 in the bigger box? Yes, 8 is in the bigger box. Now the distinction here is, what about 5? Is 5 in the bigger box? Well, the answer is no. There's only 2 things in the bigger box, 8 and a box containing 5. So 5 itself is not in the bigger box. It's only in the box inside the box. So when they ask, is the box containing 5 in the box, this bigger box, that answer is yes, because this box, the whole box, is inside of that bigger box. So yes, it's a small, difficult point here. 5 itself is not in this box, but the box containing 5 is in the bigger box. Okay, question 4 gets us back to something easier. Is 13 a member of this set? And the answer is yes. Now, when we have a U that's upside down, that means intersection. Or it means find the items in common between the two sets. So let's see, 4, 9 and 6, 8, 9. Yes, they both seem to have 9 in it. So 9 is the element that is in common with both sets. When we look at the U that looks upward, this is union. And union just means dump everything together, but no repeats. Alright, so we'd have 1, 2, 3, 1, 3, 5, 7, 1, 3, 5, 7, yes. And 2, 4, 6, 8, 2, 4, 6, 8. And the answer is yes, they've dumped all of this stuff together. Now, it makes no difference how they wrote it if we would have dumped them together and had 1, 3, 5, 7, 2, 4, 6, 8. That's exactly the same. And there you can see I've actually just dumped them together and I did not repeat anything. All right. In question 7, I've got intersection, this U again. I'm looking for anything in common. Well, there's nothing in common. Well, what's in common is the empty set. And the empty set, there are a couple of ways to write it. One way is to write it with the set brackets with nothing on the inside. Or some other times in textbooks you'll see it with this Greek symbol, which is a circle with a diagonal line, which also means the empty set. In question 8, we're looking for all of the x's where that number squared is 49. Alright, so looking for all numbers x such that x squared is 49. Well, that's going to be x is plus or minus the square root of 49, which is plus or minus 7. So there are two numbers. All right, now in this case we have U. U stands for universal set, means a big giant set. So U is universal set. Think of universal set as big set. Alright, so I got this big set, and here's set A, which has 21, 20, 22, 23, 25. So A lives inside of U. They want us to find A with a little prime symbol here. So you'll also see this as A with a line above it. It represents the complement of A. It's the things in our universal set outside of A, or not in A. So I'm looking here, where's A? 21, 22, 23, 25. What's not? What else is in there outside of A? Well, 20, 24, 26. So again, the complement is everything outside of the set, but still inside of the universal set. Alright, so in question 10 here, we have this symbol N of B. It means how many things are in B. Okay, in B. Well, let's see. Here's U. This is called a Venn diagram. So here's U, the big giant box. Here's A and B. What do I see? Well, I see A itself has 23 plus 41 items in it. B has 41 plus 26 items in it. See, there's all of B. So this big circle here is B. Now what about the 41? Well, the 41 is the number of things that's in common between A and B. And what's this 15 sitting out here? Well, there are 15 things sitting outside of both A and B. So how many things in B? Well, 41 plus 26. If we were looking for the number of things in A, well, the number of things in A is 23 plus 41. What about if I wanted the number of things in A complement? Well, where is that? That's everything outside of A. Well, that'd be 26 and 15. What if I wanted the number of things in B complement? Everything outside of B. Well, let's see. 23 and 15. So it's just a question of tracing where things are at. All right, let's see. Question 11. How many things are in A union B? So I want to find the number of things in there. So that's everything that's inside of here. Well, there's 20 in this piece, 14 in this piece, 24 in that piece. So add them all up and I get 58. A complement. All right, so let me make A a bit darker here. Here's A. How many things are outside of A? Well, 39 and 40, so 79. Question 13. Let's see. We want to find how many things are outside of A union B complement. All right, well, let's see. All of this stuff in here is, so let me shade all of this stuff. All of the stuff in blue is A union B. So I want to know how many things are outside of the piece in blue, and there are 42 things in there.